So instead of adding these fractions together with the rational denominators, we're going to decompose them. And so what we want to look at is we want to look at the factors of the denominator. So this case is an x plus 7 factor and an x plus 1 factor. And what we're going to do is we're going to set this up so that one of the factors, x plus 7, is one denominator of a partial fraction, and the x plus 1 is the other denominator of the partial fraction. And when we cross multiply this, we're going to generate the 2x plus 1 by having some group of x plus 1s and some group of x plus 7s combined to give us the 2x plus 8. Now, we do have two unknowns here, so this might be a bit of a problem. So we're going to have to come up with two equations at some point. But we know that when we add these together, we're going to get b times x plus 7 and a times x plus 1, and that's going to equal the numerator of 2x plus 8 with a common denominator of x plus 7, x plus 1. So I'm just going to set it up. So I'm going to end up with a times x plus 1, and then we're going to end up with plus b times x plus 7. So we know some group of x plus 1, so a groups of x plus 1 and b groups of x plus 7 is going to give us the numerator 2x plus 8. So that's going to be equal to 2x plus 8. Okay, so this is the only relationship I have. Now, as long as I could come up with some other relationship, or at least two relationships, we can then maybe solve this for a and b and figure out what the partial fraction is. And we're going to do it this way. So if I expand out these brackets, I end up with ax plus a. And again, notice I'm just looking at the numerator right now. So ax plus a plus bx plus 7b. We know that's going to be equal to 2x plus 8. And if I group together my like terms, I end up with this. A plus b x's plus the constants are going to be a plus 7b. I'm going to put that in brackets, group that together. That's going to be equal to 2x plus 8. Well, the strategy of equating coefficients allows me to come up with two different relationships, because I know that the coefficient on the x on the left-hand side of the equation must equal the coefficient of x on the right side of the equation. That's going to give me one of my relationships. So I can say that a plus b is equal to 2. I can also say that my constant term set a plus 7b must be the same as the constant term on the right-hand side of the equation, which is 8. And that then generates the second equation I need. So I end up with a plus 7b is equal to 8. And I can kind of guess what this is. A is 1, b is 1. But I can solve this as a system of equations. I can solve for b. B is equal to 2 minus a. And then I'm going to replace the b in the second equation. So instead of 7b, I'm going to replace that with 2 minus a. And that then gives me one variable to solve for. In this case, I only have one a to solve for. So I get 7a plus negative 7a, or a minus 7a is going to give me negative 6a, plus 14 equals 8. So negative 6a, or I'm just going to write this as 6a is equal to, I'm going to move the 6 to the other side, and I get 6a equals 6, or a equals 1. If a equals 1, I can solve for b. b is equal to 2 minus 1. And so b is equal to 1 as well. So there's my a and b, which allows me to work out my partial fraction. And so my partial fraction is going to be 1, or a, divided by x plus 7. So that would be this fraction here, plus b is equal to 1. So I end up with b over x plus 1. That's this fraction here. So now I've decomposed my original fraction here with the factors x plus 7 and x plus 1 in the denominator into this partial fraction, which is breaking down, undoing that addition that we had before. So we went from our added fraction of 2x plus 8 over the common denominator into separate fractions using each of those denominators. Okay, so let's try another example of this. So again, the way we set this up is we want to just say that there's some a and some b over the factors x plus 1, x plus 2, and x plus 5. When we get a common denominator, it's going to generate the numerator 2x plus 7. So we'll set this up the same way. We know that a times that is going to be one of the terms. So we end up with a times x plus 5. And that's going to be added to b times the other term. So x plus 2 times b. So I get b times x plus 2. And when we combine that all together, we're going to get the new numerator, which was the answer to our addition, 2x plus 7. So that's going to be equal to 2x plus 7. Now to solve for a and b, we can group our a and b coefficients. Okay, we're going to group our a and b coefficients. I'm going to do that by expanding. So ax plus 5a, so that I have an x term and a 1's term. Here I'm going to end up with an x term bx plus the constant term 2b, and that's going to be equal to 2x plus 7. Now with two variables, I need to come up with two equations. The two equations are going to be based on the coefficients. This is called equating coefficients. So ax plus bx is a plus bx. And we know that that has to match, that a plus b is going to match that coefficient of 2. Grouping together my constants, I end up with plus 5a plus 2b. Those are my two constant terms. When I add those together, that's going to be equal to the constant. In this case, the constant is 7. So that 7 is equal to that. So this is where I'm going to set up my system of equations. I end up with one equation is a plus b equals 2. And then the second equation is going to be 5a plus 2b is equal to 7. Some of you may be able to guess the solution here. I'm going to substitute. So a is equal to 2 minus b. And this could be, previously I solved for a. This time I'm going to replace a and solve for b. So I'm going to replace the a in this equation. So instead of 5a, I'm going to use 2 minus b plus 2b equals 7. The only variable left is b, so I'm going to end up with 10 minus, when I combine the b's, negative 5b plus 2b is 3b equals 7. So I get 3 is equal to 3b, or b equals 1. Okay, so that's one of the solutions. Solving for A, I just substitute for B. So 2 minus B is equal to 1. So A is equal to 1 as well. Okay, now these are, some of these you might have been able to guess, but I've given you some easier examples here. So my decomposed fraction then becomes A. So it's going to be A over x plus 2. Okay, that's going to be that fraction there, plus my b is equal to 1, so I'm going to end up with b over x plus 5. And when I crisscross and add the numerator, I'm going to end up with 2x plus 7. Okay, so this is now my partial fraction, which is undoing that addition.